the naming node. The naming node manages all the information, metadata. It's a repository of the metadata. And on the other hand, the data node keep all the data part. Okay, so that is the reason the naming node is called a single point of failure, which means that in case this one is down, no way to access the data. However, in case that one of the data node is down, we still have the two other copies, so we can use. So there's a way to recover. So for example, later if the data is crashed, if this one node is recovered but data is not, at the time we can copy such a data, make the copy of the block, something like that. Okay, so this is a naming node. Naming node is the metadata repository. They use the memory for the efficiency. Okay, so you need the RAM, the bigger size of RAM when you set up the big data the Hadoop system. By the way, nowadays when you insert the Hadoop system for your network, for your system, you don't have to worry about. Even when you download the Cloudera, for example, you can use a Cloudera, which is based on the Hadoop. The Cloudera manager knows the capacity of the server, so assign. This one is a data node, this is a naming node, and this is a data node too, something like that. So you don't have to, you can just click, and that's it. However, to understand the architecture of the Hadoop, so I will use the old-fashioned, the manual setup. Okay, so you need to update the configuration file. So because of that, if you are not very familiar with the Linux interface, especially the VI editor, there's a way to update the data, the text file using the graphical user, it's a gedit, graphical user interface text editor. But if you know the VI or command line interface or Linux command, that will be much helpful. Which means if you are not very familiar with such an interface, why don't you try to learn this time? Okay, I'm not going to ask in the exam what is the command, but for your practice, why don't you spend a little time? Anyway, so this is the naming node is kind of the coordinator or the master node. Okay, so we will see the other material to understand the Hadoop I/O. So through that material, you will pretty much understand. But anyway, this is a command Hadoop fs to use the distributed file system. Oh, before we use this one, definitely each and every node should have the HDFS component as well as a MapReduce component, which means after installing the Hadoop, so you will be able to use such a command Hadoop fs command. Next week, we will have the first exercise slide, which means you need to bring your laptop after downloading the virtual machine. There are two virtual machines. There are two links on the the Canvas class site. So one is the administrator, another one is the developer. Why don't you download the developer? Okay, so it's a good idea. Make a copy of them. Just in case it messed up, you can just copy it again, overwrite, and start it again. So that is the Hadoop command. So next week, after we have the 1 hour lecture, the other part, we will have the exercise lab. Mostly you will learn how to use the Hadoop command. Okay. Then MapReduce programming. So after that, the week after, we will start. From next week, we will learn the MapReduce programming. Then after we completed the lecture, then we will practice the MapReduce programming also. Okay. There are several important characteristics of the MapReduce. Okay, it's automatically parallelized, so you don't have to worry about in your program. Just implement your algorithm, focusing on your algorithm. Then all the other part will be taken care by the MapReduce component. Okay. So also it's a fault tolerance. Even though one of the current job is a fail, part of job task, which is called the task, is a one job is you submit the ABC, the job, okay, to count all the flu query. Then it will be divided by several tasks. So that is a task. So in case one of the tasks is a fail, then it will be recovered. It's an abstraction, which means You don't have to care about the much detail inside. Just focusing on your algorithm. However, it is true. The MapReduce programming is not very straightforward. It needs experience to learn the first time. So not very difficult, but when you have the more and more experience, it's getting harder and harder. It's a designing problem. Okay, it's not a programming skill problem. Okay. So even though it's not very clear, so I will introduce more in details the next class. So regarding to the MapReduce. But basically, if we have a storage like this one, each task will extract a key plus value. How can MapReduce extract the key plus value? You need to assign. So this will be key, this will be the value. And not only just a one-time extraction, sometimes it's a sequence of extraction until you get the data that you want, key value data you want. Okay? Then the key value will be combined in the reduce the step. Reduce mapping job is locality, which means one task per block. But during the reduce, it doesn't matter. Sometimes you have only one reduce. Sometimes you have a multiple reduce. So you should be able to decide how many reduce. The number of mapper is automatically assigned based on the number of blocks. But the number of reducer, you need to design. One reducer, sometimes there is no reducer. Output of mapper will be just output. Okay. So this is a job tracker. It's kind of, this job tracker resides on the master node, not the client node. Okay. Job tracker is kind of the coordinator of your job. If you submit the one program, that is one job. Then that one job will be divided by the number of the block, that is number of tasks. Okay. However, nowadays job tracker actually has include all of this, but in the yarn, yet another resource manager. Doesn't make sense. It's a yarn, and this is an M. What's the problem? Manager. Anyway, so job tracker is divided into the three groups in the yarn. The MapReduce, the Hadoop version 2. That is, one is a resource manager. Another one is an application master, which means one for each. Yeah. So, but in the traditional, the MapReduce one, the only one job tracker will take care of everything. And the timeline server is for each task. So manage all the history of each task. So there are three parts. But in traditional, all these are included in the job tracker. The benefit, we will see the benefit of the yarn in the separate file I will introduce. But in our implementation and practice, we will use the version 1, which is much easier to understand. And later when you get used to it, then you can use the yarn. So yarn is not a program MapReduce version 2. Some of the book mentioned yarn is the version 2 or version 2 of the MapReduce. No, I don't think so. Yarn is another approach for the resource manager. So yarn can be used for non-distributed file system, single load file system. It can be used for any kind of the architecture. Not only the Hadoop, but also it can be used for your Java program. You can use the yarn, the package, you can import in your Java program. Then use such a resource manager. But in traditional, the version 1, old version of the MapReduce, you cannot use any other the system. Only in the Hadoop system you can use the MapReduce program. Okay. So job tracker will take care of all task tracker. Okay. Then task tracker is assigned to the machine where the block is located, which is called locality. It keeps the locality. But reduce actually is not locality. If you assign only one reducer, then it's only one. The other, they don't care the reducer. So that is a locality node and task tracker. So how can you create and run the MapReduce job? You need to use the Java programming. So then after coding, then compile using the JavaC. Then you need to make the jar file. What is the jar file? It's a Java object archived file, like the zip file. So you can combine all class file into one. Then using the Hadoop command that you are going to practice the next week, you will execute you can submit the MapReduce programming. So if you are very familiar with the Java, it's very easy. Okay? Otherwise, it's a good time to learn the Java program. It's definitely good for you. So naming node, secondary naming node, data node, job tracker, and task tracker I introduced already. Well, what if we learned all 5 daemon programs? Yes, technically possible. That is a pseudo cluster. It's a fake cluster. So you are going to use a fake cluster in your first exercise. Okay. Also, they are running on top of the Java virtual machine. So from time to time, you need to check whether daemon process are running correctly. So you need to check whether process are alive on the list. That is this job tracker, name node, secondary name node, or the task tracker for each data node. These are the details of the what I explained. Overall, what I explained is here, and including the Java object or the Java the function that you need to use. Okay. This is the MapReduce. I will introduce more the details step by step in the next class regarding to the MapReduce. Okay. Then others, which is in addition to what are 2 main components of the Hadoop system: HDFS file system and MapReduce, the programming framework. In addition to them, there are many other components that help. For example, there's no indexing. There's no random accessing. Is there anyone? So HBase is a Hadoop database, can be useful. Also, MapReduce is very, very difficult to learn. Is there any way to use a SQL style query? Yes. So that is a Hive, for example. Hive is not the database. Somebody confused. It looks like the database, but it's an interface. SQL-like the interface to access the HDFS. Then automatically it converts the SQL style command into MapReduce program. Okay. So what we see? Such a component. First, HBase. It's not hierarchical database. It's a Hadoop database. It's based on the key value, and also it supports the updating data and indexing. So we will see a little bit more the HBase in the semester. Okay. So it's one of the representative NoSQL database. What is a NoSQL database? It's the opposite of the relational database. Kind of. Relational database? Yes.
Actually, in SQL database, we write we define the structure here itself, whereas in NoSQL, we don't define any structure.
Yes, that's the key point. So, relational databases such as Oracle has very strong data structure, relational model. So you define the entity, the student table. The student table has the name, it's a character 10 byte, and the ID, the UV ID is the 7-digit number, and so on. It's a very strongly defined. So sometimes data doesn't fit to your data structure. You cannot insert. So you need to change. Even you need to change your data structure, like the locations, multi-valued column. Is it possible to keep the multi-valued column? No way in the relational database. Okay, but NoSQL database to address such a very strongly structured database is more flexible. It's the unstructured or semi-structured data, like the document, XML file, or log data can be stored at the HBase. Okay, it's based on the column-based database. What is a column-based database? What is a row-based? Column and row-based. Think about the relational database. How many columns? 10, 20, 30, 100? Right? How many rows? Millions. 10 million. Sometimes more than 10 million. Then we have been focusing on to access the specific data very quickly. Specific row, specific record. Right? To do that, we need the query optimization, query processing, indexing. What if? To find the column. So our traditional data is like this one. What about this one, which means millions of columns? Is it possible? Yes. Think about the sensor. So we have the millions of sensors. Sensor 1, sensor 2, sensor 3, sensor 4. Each sensor is a column. Then distribute to check the temperature in United States. Then collect the data every hour. So every hour is a row. How many columns? Millions of columns. Sometimes I need the specific column data. We need to optimize it. We need to have the index that is a column based. Sometimes we do not specify the specific column. Column can be state column. We need to be flexible to define such a state column, Connecticut column, or the northeast column. So that is a column based. Okay? So HBase is a column based data. We will see later. So anyway, as a repository, it used Hadoop HDFS. Okay? So it used HDFS, and on top of that, there is HBase. This is a comparison between the HBase and relational database. Later we will see details, but HBase can support much bigger than the petabyte size level. Okay? And also it can process millions of queries. Okay? Hive, as I said, MapReduce programming is too hard. It's true. Comparing to the SQL, how long it takes to learn the SQL? Just 1 or 2 days, the lecture are enough to learn the SQL. Very straightforward and the user friendly. What about the MapReduce? First, you need to learn the Java and compile it, and you need to know the API and whatever. So also, more important thing is you need to design the key value. Okay? So because of that, the company like the Yahoo and Facebook, they realize it's not very practical. So we have the developer here who are familiar with SQL. So it takes a long time to learn like the 1 month for all the employees should have the training course and even takes some time. So why don't we make something different interface that's similar to the SQL? So like instead of the programming, select specific column name from the file name, some condition if needed. So that is the Hive. The Hive is a SQL style. The query, it's not query language, but anyway, interface. But don't be confused. There is no repository for Hive. They use the HDFS. When you submit this one, it will be converted to MapReduce program. Okay? Pig, oing oing. So this is another interface developed by Yahoo. Okay? Yahoo realized that this Hadoop is very nice, but you cannot fire all the employee developer. Okay? Then hire the new employee who knows the MapReduce. No, you cannot do that. So they develop the script language like this one. It's much more simple and very effective. So like you can specify the load. It's a straightforward. Load the stop file from the HDFS as ID, and even you can assign the specific name. Then group by order, group by ID, group orders by ID, and for each you can. So it's you can reduce the developing time. What happens when you submit this one? Convert it to the MapReduce program. Okay, this is a big. So in your project, you can use. I think that I emailed you this afternoon. It's a stock market analysis using HBase. So the student upload the last 20 years of the stock market history data to the Hadoop. Then he used the Hive query. It's just a simple query, yes, okay, to find the top company in terms of volume. Volume means sum of amount. It will take a time if you are using the Excel file, right? It's limited because the 10 years, 20 years stock market trading history is huge data. But using the Hive, even you don't have to implement the MapReduce programming, just submit the Hive query to get such a data and visualize. That is example of the using the big data system, Hadoop system for data analytics. Okay? You can think about the similar thing in your programs. Problem, whether you are able to get such a data. That's really important. So that is the reason. First step is getting the data. Okay? And flom and scoop. What is a flom? When I was young, in my hometown there was an amusement park. In the amusement park there is something roller coaster, right? And there is a flom ride roller coaster, which means there is the water, right? Like the roller coaster, then it's a log. The inside the log, we can sit on there. So, for example, this one. You know this? It's a flom ride. It's a roller coaster. Flom means it's a flow, data flow. It's a software you can get the data from existing relational database to the Hadoop system. Automatically, the transfer the data, like the flom ride. Okay, that is a flom. And scoop means, flom is from any data source. I'm sorry. Flom is from any data source, like the log data or others. Something sensor data, something other data source. Then get the data into the HDFS. On the other hand, the scoop means only from RDBMS, because it is true. Still, the RDBMS is the main repository of the data. Also, most important data are there. So from the relational database to get the data into the HDFS, at that time you can use the scoop. Scoop means it's a scooping, right? So you can scoop the data from relational database. Who will practice both of them? So that is a flow and unscoop. OC is the kind of the flow, data flow management. Okay? So workflow management. So because not only just one MapReduce programming, sometimes we have 1, 2, 3, depending on the output of the third MapReduce program, either this MapReduce, right? Then it's a workflow management. Okay? So that is the each and every component ecosystem we will cover the rest of the semester after MapReduce programming. Why don't you take a look at the handout. I found that the comic book from internet a couple of years ago, 2 years ago, but it's not updated. So still the same, but it's one of the easiest way to understand the Hadoop architecture using I/O. Even it explains the many of the component, the functionality used in the Hadoop system. So I don't think that we have a time to take a look at details, but roughly I'm going to explain. So this is a client. Client is what color? It's purple. Yellow is the name, and the other colors represent the data node. Once we have the data node, from the client, it starts from the always a client to upload or the download or read, write the data based on what block size. So first you need to contact the naming node. Okay, so naming node. So for example, when you upload 200 megabytes, it will be 2 blocks. And how many replication copies? 3 copies. Then the naming node knows which node are available, also which node are close and in order. So give the information about data node 1, data node 2, data node 3. Then contact. What kind of information? Probably IP address and port number. Using that, contact this one, then send the data as a string. So while the node 1 is receiving the data and writing the data and send to the next node. Once it is done, and they contact the naming node, not this way. Once all data is right to the hard disk drive and done. I'm confused. Let me correct. So once each node is done, they inform to the naming node directly. I thought it's this way. Let me check. Okay, then when you write the data, so it's quite similar. When you read the data, it's quite similar. So ask the naming node, then the naming node has the information about the block 1 is available on this. Then based on the distance information, then contact the directly data node and get the data. Okay. Then also they are sending the heartbeat every 3 seconds. The naming node recognize which node are available, which node are not. Okay. Pretty much. In case of failure, like no heartbeat for 10 minutes, something like that, then they can use the metadata information and ask to access the other available node. Okay, so why don't you take a time to understand the Hadoop I/O using this one? Then why don't you read the textbook, other definite guide. I know it's a little bit boring, the textbook, but once you get used, it's not very difficult to understand the concept of the Hadoop. Okay. Then, pretty much that's it. Today's lecture. I little bit speed up, okay? But next week we will start the MapReduce programming. Also, I think the next week, and anyway, next week we have class. So Monday is the holiday, only Monday, and Tuesday is the regular day. So we will have the lecture for the first half, and second half will be the exercise lab for the not MapReduce programming yet, the HDF, the Hadoop, the command, okay, and how to load the file, how to download the file, okay, and basic command that you will. Okay? So bring your own device after downloading the virtual machine, not administrator, the developer. Okay? Any question? Okay, thanks so much, and we will see